Hey, algebra. So we have just two quick examples here that we're going to do together. This first one says, find an equation of the axis of symmetry and the coordinates of the vertex of the graph for this function. Is the vertex a minimum or a maximum? So hopefully by now you're thinking, how do I find the vertex? And your brain should be like, oh, negative b over 2a. That is your friend. So we're just going to plug in. Here's my b, so 2 over negative 2 times my a value, which is negative 2. 2 over negative 2 times negative 2 is positive 4. And then simplifying, I get 1/2. So now we just found our axis of symmetry. Our axis of symmetry equals x equal to 1/2. Now how do we find our y-coordinate of our vertex? Remember, we plug back into our equation. So y of half equals, now let's plug it in. Alright, so this is a review. Remember, we have an exponent on the outside. You distribute to both parts here. So I have negative 2. 1 squared is 1. 2 squared is 4. Plus half of 2 is 1 minus 6. Remember, this is really over 1. So negative 2 times 1 is negative 2 over 4 minus 5. Simplifying. What's negative 2 over 4, guys? 1 over 2 minus 5. Subtraction means add the opposite, so we end up at negative 5.5. Unless we did our math wrong. And as in we, I mean me. So we found our vertex, we found our axis of symmetry. And then the last part says, is the vertex a maximum or a minimum? So in your brain, you got to be thinking, how am I going to tell if it opens up or does it open down? Because if it opens up, this is a minimum. And if it opens down, here's my max. And remember, how you find that out is you have to look at your a value. So what is our a value here? It's negative 2, so it's going to open down because it's negative. So that means my vertex must be a max. So our vertex is a max because it opens down. Good job, guys. Nice work. Now we're going to turn it over. Now this should be a problem similar to the one you ended with yesterday in classic number 26. So if you had issues on that, maybe doing this problem together will help you figure out what you did wrong. So let's read the problem here. It says, entertainment. During halftime, a basketball game, a slingshot launches t-shirts at the crowd. A t-shirt is launched with an initial upward velocity of 72 feet per second. The t-shirt is caught 35 feet above the court. How long will it take the t-shirt to reach its maximum height? What is the maximum height? What is the range of the function that models the height of a t-shirt over time? So, what we got to be thinking here, guys, is when I shoot a t-shirt, it kind of has a motion like this, and I'm shooting it, and then it's going to fall at some point. So it's quadratic because it looks like a parabola. And again, your maximum height, guys, that is just your vertex. We got to find our vertex. So now it's like, well, what am I going to do? Well, now we have this formula we use. So when any object is projected into the air, this is our go-to formula. H of t, so height over some period of time, equals negative 16 t squared plus vt plus c. Don't get bent out of shape because there's just a lot of variables, but it's not so bad. We just plug in what we know. H is just represents height. T is our time, V is our velocity, and C is how high did our objects start. I gotta scroll down here. Okay, so let's write our formula. So it's going to start with H of T equals negative 16, because that's part of my formula. It stays. T squared plus, now what's my upward velocity? Let's go back up to our question here. They told us the t-shirt is launched with an initial velocity of 72 feet per second. So plus 72 feet per second plus, how high did we start? Does it tell us? Well, no, but if we look at our picture here, folks, you see that? I don't know if you can see that pink maybe. Our people are about 5 feet tall, so that's what we're going to plug in. Our initial height was 5 feet, so plus 5. So now we have to find our vertex with this formula. And that will give us our maximum height. So again, that's just good old negative b over 2a, negative b over 2a equals, so let's start. Negative b would be negative 72 over 2 times negative 16. Are you with me? Now I'm just simplifying negative 72 over negative 32, and then just dividing that out, I get 2.25 seconds. So this just tells me I'll reach my maximum height at 2.25 seconds. So now let's plug in to figure out what our height would be. So now I'm going to put finding height. So I'm going to plug in 2.25 in for t. Negative 16 times 2.25 squared plus 72 times 2.25 plus 5. So negative 16 times 2.25 squared is negative 81 plus 72 times 2.25 is 162 plus 5. Now adding those three numbers together, we get a total height of 86 feet. So we just found right here the max height. This is our vertex. This is our vertex. Now let's kind of scroll back up here. Bear with me, folks. Bear with me. So it says, what is the max? Okay, how long will it take the t-shirt to reach its maximum height? Well, we just found out it will take 2.25 seconds. So where should I write this? We're going to go like this. Like this. Hope you guys can't see this. You'll see in a second, though. Okay. Oh. Hold on. I'm almost done. Almost done, I promise. This is just silly. Third time's a charm, right, guys? Hold on. All right. I just wanted a blank slate. Okay, so how long will it take the t-shirt to reach its max height? Max height occurs 2.25 seconds after launch. Okay, so we'll call that part A. Part B, what is our max height? Our max height is 86 feet. What is the range of the function that models the height of t-shirt over time? So think, guys, your range is your y value. So your height. Your height is represented by your y's. So height equals range. So let's start with the easy part. Can I go into the ground? Am I going to have a negative height? No. So my range is greater than 0 because I can't have a negative height. And what was our max? What was our max height, guys? 86 feet. 86 feet. So that is our potential range of our height. Okay? Hopefully that makes sense. You have a gold riddle worksheet for homework tonight. Good luck. Help each other out, especially help the people out that were gone and are probably super, super lost. Be their friend. We're all friends. We'll see you later. Have a good day.